VS series. Profile position and profile defect tool. The profile position tool divides the main inspection region into smaller segments and locates an edge within each segment. It detects the minimum and maximum position and can calculate a best fit line or circle from the detected edge data. It can scan for edges in the X or Y direction or radially when a ring or arc region is used. The profile defect tool also divides the main region into many smaller segments and locates an edge within each segment. It then calculates the reference profile shape from the detected edge data, which can be a circle, line, oval, or free curve, and detects any edge point that deviates too far from the reference profile. It can scan for edges in the X and Y direction or radially when a ring or arc region is used. Connect to the profile position, profile defect simulator, and play through the images. These test images will be used to explain the main settings of the profile position and profile defect tool. There is a blob tool added in advance for position adjustment purposes. Add the profile position tool to the task. In this example, we will add it from the position alignment category. Using image number 1 in the film strip, draw the inspection region to inspect the left side of the target. The profile position tool will break the inspection region into many smaller segments and locate an edge in each segment. Set up the edge detection conditions as needed to get the desired edges. Refer to the edge position tool video for more details on the edge detection conditions. In this example, the scan direction is forward, so in this case it's going left to right, and we will set the edge direction to dark to bright. In the options settings, you can set the segment size and segment shift as needed for the application. In this example, we will set the segment size to 5, which is 5 pixels wide, and then we'll shift by 3. You can see that it runs out of segments. That's because the maximum number of segments as a default is set for 100. So raise that number as needed to get all of the desired edges. As a default, the judge label type is set for maximum, which will display the maximum segment in green. If we play on image 2, you can see it highlights the maximum point, and then image 3 here. You could also set it for the minimum point, which would show the minimum position. In this case, the point that's furthest to the left. Or you can specify which segment you want to display or use as the judged label. For this example, we will leave it on maximum. The profile position tool can also be used to calculate the best fit line or circle based on the edge data. So in this example, if we set this to line, we can detect the best fit line from the data points. If there's some large outlier points and you want to correct for that, you can turn on the deformity correction. The tool results will be displayed in the results section. The number of detected segments is the number of segments that have a valid edge detected. Distance is the distance of the judge label, in this case the maximum. It will also display the maximum and minimum distance, as well as the line information, best fit line. Once you have your desired detection conditions set, you can set the judgment limits on the tool. So in this example, we can set an upper limit on the maximum distance, and then a lower limit on the minimum distance. So if any of the detected edge points fall outside this range, the tool will not pass, it will fail. Now we will copy this tool and perform the inspection on the top portion of the part. So just copy the region or copy the tool and rotate the region by 90 degrees. So the scan direction will be top to bottom in this case. and it will do the same thing. Look for the min and max points. So you may need to adjust the limits accordingly. So let's do that, and it will perform the inspection on the top portion. The line information detected from these tools can also be used in other tools, like the intersection between two lines. The profile defect tool is very similar to the profile position tool, but the profile defect tool will detect and analyze edge points that deviate too far from the reference profile. Add the profile defect tool from the flaw detection category. Draw the inspection region to inspect the left side of the target, just like we did in the previous tool. For the edge detection conditions, we'll use the same type of setup we had in the profile position tool. So change the edge direction to dark to bright, and under options, you can see the segment size and shift are already defaulted to 5 and 3, so we will keep those settings. So the detection conditions for the profile defect tool are the same as for the profile position tool. The defect detection conditions will determine what a defect will be. The reference line setting is the best fit profile shape to calculate from the detected edge points. In this example here, it defaults to line, so it's calculating the best fit line from those detected points, just like it did in profile position. But you can also choose circle, best fit circle, or free curve, which is a free curve shape, so it adapts and calculates the best fit free curve shape. In this example, we are going to leave it on line. The detection threshold is the setting that determines how far the actual detected edge point can be from the reference line shape before it becomes a defect. So as a default, it is set for 3, which is 3 pixels. So any of these detected edge points that fall 3 pixels or more away from the calculated reference profile line shape will be determined defective segments. For this example, we're going to leave it on 3 for the detection threshold, but you would adjust that as needed, depending on the type of defects that you're trying to pick up on. As you can see in this example on image number 2 in the film strip, we are detecting 1 defect. So the defect count is 1, as you can see in the tool results. So each defect will have, or will calculate, there'll be a defect size, level, and width. So the width of the defect is how many edge points or segments in a row have passed that threshold. So that's the width of the defect. The level is the peak point, the one that's furthest away. So whatever edge point is furthest away, that's its level. So that's in pixel units. So it's, in this example, it's a little bit over 67 pixels away, the peak point. And then the size is basically all the levels added together. So all the distances away these edge points are, it adds them up and gives you an overall size of that defect based on those detections. If we test image number 3 in the film strip, you can see this target contains 2 defects. So the defect count is 2. The tool will differentiate between a defect that occurs on the left side of the line or the right side of the line. In other words, forward or reverse. So as a default, it will detect both, but defect scan direction can dictate which defects you are looking for. So if you set it for only plus defects, it'll only look for defects that occur in the forward direction. If you set it for minus, it will only determine or detect defects that occur in the reverse direction, and that's the direction of your rotated rectangle region. So that the direction of that arrow is forward, the opposite direction is reverse. You can also set it to individual setting, where you can individually set a separate detection threshold for the plus range and the minus range if that's needed. We'll leave this on the standard plus and minus setting. You can view all the tool results in the results window here. The tool results are the overall tool results, so it'll give you a defect count overall, a separate count for plus and minus. It'll give you a total defect size, level, and width, and then a defect size and position of the judge label. You can also view the label results here, which will show you the individual size, level, width, and position of each detected defect. So you can also get a position of each defect. You can also filter out any unwanted detections by using these filters here. So you can filter on level, width, or size. So for example, in our example here, one of the defects has a width of 6, the other defect has a width of 4. So if we wanted to filter out or not count the defect that had a width of 4, we could put a lower limit to the width filter of 5. So it has to be less than 5, or any detection less than 5 will be filtered out and ignored. So you can filter out unwanted noise if desired. For this example, we will not filter anything out. Let's put that back. The defect detection count is the maximum number of defects to count. So as a default, that's set for 30. You can change that as needed, depending on the application. In the options settings, you can set the detection order as needed. As a default, it'll just sort the defects in defect size descending order. So the biggest defect will be the first target in the list, and then it will number them accordingly. You can also set the judge label here as well. As a default, the judge label will be the first target in the list, or target 0. The judge label is the target that's listed or displayed in the main tool results here under total defect size. So the size, level, width here, that's of the judged label. So once you have your detection condition set, you can then set your judgment limits, your pass-fail conditions. You could set a limit on the number of detected segments, which are segments that have a valid edge point. The defect count, which is the overall count. You could even set limits on the individual plus count and minus count, as well as the total defect size, and then the size and position of the judge label defect. In this example, we'll put an upper limit of 0 to the defect count. So if there's any detected defects, the tool will fail. So you can see image number 1 passes because there are no defects detected. And then image number 2 fails because there is a defect detected. And as you've seen in image number 3, it fails because there are 2 defects. Let's do another example of the profile position and profile defect tool. Change to program number 1 in the simulator. This time it will be on a round type target. So again, there's a blob tool added in advance for positioning purposes, and we will inspect this circle target. So let us add the profile position tool, again from the position alignment category. And this time we will change the inspection region to a ring. So choose ring and draw the ring to enclose the target. When you're using a ring or arc, basically you want the edges that you're going to be looking for, in this case the outer and inner diameter of this ring, need to be in between the rings of the inspection region. So we'll look for edges in between these rings. So again, the profile position tool will break the region up into many small pieces and look for edge points within each segment. This time, since it's a ring, it's going to be an angular piece. So, but what we'll do is you can set up the detection conditions just as before. So right now we'll go from the center out and we'll look for that first bright to dark change we see here. So again, it's going to scan for edges in between the rings. So let's look for this bright to dark change. And under options, you can set the segment size and shift as needed. This time, if you're using a ring or arc, it's an angular dimension, so it's 5-degree shift and a 10-degree size. So for this example, we'll set it to 5 degrees as far as the segment size and 3 degrees for the shift. Now, we do need a few more segments here, as you can see. So let's change the number of segments to 200, and it is going to profile this circle, as you can see here. So you can adjust these settings as needed. And down where it says best fit circle line, let's change it to best fit circle. So when you're using a ring, you can detect the best fit circle. But just like before, we can get the maximum and minimum radius points in this case, since it's a ring. And then we can also calculate the best fit circle. Once you have the desired detection conditions set, you can set the judgment criteria on the tool so it can pass and fail. So as far as the radius value, and by the way, the radius value is right now it's in pixel units and it's in reference to the center of the ring here. But we could set an upper limit on the maximum. So you can see in our good part, it's a little bit over 206. So we could set a limit appropriately, put an upper limit, and then we can put a lower limit on the minimum radius. So if any of the values fall outside this range, the tool can fail. So if we go to image 2, you can see it fails because the maximum radius gets too bigger because we have a little defect there. Image 3 also fails because of the shift in the target here, and the max and min radius fail. If you go back to image 2, notice the best fit circle here that's in green gets shifted a little bit by the defect, of course. So if you want to avoid that, one thing you can do is go back to detection settings, and in the best fit circle calculation, you can turn on deformation correction. So what it will do is when it calculates that best fit circle, the one in green, it will not be affected by anomalies like this. So, and then we could use this circle in other calculations in the dashboard or in other tools. So now let's do the same thing, but for the outer surface here, the outer out profile. So let's just copy the same tool. So copy it and paste it. And now I'm going to go back to image 1 temporarily. And then what we'll do is, we'll just simply change the direction from center to out to center. That way it's getting the outer edge this time. So again, the min and max radius. Now we need to adjust the limits because now we're doing the outside circle. So let's just adjust those limits accordingly. But now we can inspect the outside circle. So the first target is good. Again, the second target is bad because of the min radius fails. And then again, this last target actually passes okay because the outer ring is good. All right, so now if we want to, another thing we can do, now that both tools are calculating best fit circles, let's say we want to compare the center to center distance of those best fit circles for concentricity. So let's add another tool and let's go to the measurement and dimensions category, and we can do a distance, and we could do a circles distance. So in other words, the distance between two circle centers. If we add this tool, we can click the two circles. So we can click the inner circle as the first circle, and then the outer circle for the second circle, and it will calculate the distance between those two circle centers. So if they're nice and centered, the distance will be really small. So in images 1 and 2, they are good, but the third one, they're off center. So you can see this distance increases. So again, we could set a judgment on that. We can do an upper limit, let's just say 2. Again, it's pixel units right now. So we can put a little bit of 2. If it goes more than 2, we can fail it. So these first 2 parts are good, and then this one fails. So you can use that circle information in other tools to calculate, like, for example, the distance between circles. And finally, we can also use that profile defect tool to analyze defects. So add the profile defect tool from the flaw detection category. And we'll do the same kind of setup. We'll set up a ring as far as the inspection region. To analyze the profile of this target. So we'll pretty much set it up the similar way to what we just did. For the first one, we'll do bright to dark, center to out, and under options, you can see 5 and 3 are the default size and shift when you're using profile defect. So we'll leave that. We'll leave everything else default. So if you notice, it is now finding the defect, and then we can get the information on the defect, just like we did on the other target in the previous exercise. So what we can do then is we'll leave everything else default, but you would adjust everything else as needed. It's going to calculate the best fit circle this time from the edge information, and then it's going to look for any of those edge points that deviate too far from that best fit reference circle. So if we go to judgments, just like before, we'll go ahead and just set an upper limit of 0 for the defect count to fail it if there's any defects. And then what we can do is repeat that exact same thing for the outer circle if we'd like. I'm going to copy and paste this tool. So then we'll change the direction from center to outer to center, and it will perform the same inspection, but on the outer ring.